Hi everyone, good morning. My name is Karthiksai Chenna. Today I'm excited to talk about hyperautomation in SAP production planning in Conf42 DevSecOps 24. I would like to just briefly give a couple of details about me. So I'm a senior SAP delivery lead with my interest leading toward digitalization of supply chain process. My focus is on changing the way companies operate and utilize technology so tomorrow's vision can become today's reality. It's been a 15-year passion that has taken me around the world and continues to deliver results with the most competitive markets. I have received Titan Business and Innovation Award, Global Leadership and Business Transformation Award, and I have been judged in many conferences. Now, going back into the topic of hyperautomation in SAP production planning, below are the table of contents. We'll go through the key components, benefits, case study, impact on production planning, technologies powering hyperautomation, challenges and ethical considerations, the future of SAP, PP, and hyperautomation. So going back into the introduction of hyperautomation. Hyperautomation is more than just process automation. It integrates cutting-edge technologies like AI, machine learning ML, robotic process automation RPA, and process mining to create a fully automated, intelligent production planning system. Before diving into the details, let us consider this. Gartner predicts that the market for hyperautomation enabling software will grow to 860 billion by 2025. 860 billion is too much, underscoring its transformation potential. So how does hyperautomation revolutionize SAP production planning and what does it mean for manufacturing operations? So let us explore the key components of hyperautomation. So the key components are RPA, AI, ML, and process mining. Hyperautomation integrates several powerful tools. Let's break down the key components. Robotic process automation. So RPA automates repetitive rule-based tasks such as data entry and order processing. It not only accelerates process by up to 70%, but also reduces human error significantly. We all are worried about human errors. Artificial intelligence. AI leverages production data to provide predictive insights. For example, AI can forecast demand with up to 95% accuracy, enabling better production alignment. The next one is machine learning ML. ML models adapt dynamically to changing production requirements. These models optimize production schedules, improving efficiency by around 20%. The next one is process mining. This technology identifies inefficiencies within the workflows. For example, process mining has been shown to reduce production cycle times by up to 15% by pinpointing bottlenecks and suggesting improvements. So the next topic is what are the benefits of hyperautomation? Now let us discuss the tangible benefits, efficiency gains, accuracy improvements, and real-time insights. So on efficiency gains, by automating manual process, hyperautomation reduces lead time by 25 to 40% and improves resource utilization by 20 to 30%. Accuracy improvements. Forecasting becomes more precise with accuracy improving by 15 to 40%, while inventory levels can be reduced by up to 25%. Forecasting is one of the key components in manufacturing. In any production facility, the demand is always generated by doing a forecasting. Sales people will go about doing forecasting and they will give the demand to the manufacturing leads, and the manufacturing leads will pass it on to the floor operatives where they will try to meet the demand by manufacturing the required product. Time insights. IoT devices and advanced analytics provide real-time monitoring. For instance, downtime can be minimized by 25 to 45%, and detection and response times are reduced by 50%. Ultimately, hyperautomation drives faster, more accurate, and flexible production planning, allows organizations to adapt to shifting market demands. So these are the benefits. Now, going into a high-level case study. So let's look at a case study to see hyperautomation in action. A leading automotive manufacturer faced challenges with complex production ecosystem by managing the resources and on-time deliveries. Their solution included RPA to automate scheduling and reduce manual workload, AI For predictive maintenance, which achieved a 90% accuracy in predicting equipment failures. ML to optimize production schedules based on historical data. Process mining to identify workflow inefficiencies and reduce unplanned downtime by 35%. The results? A streamlined production planning, enhanced resource management, and higher on-time delivery rates. This case demonstrates how hyperautomation can drive measurable impacts. So going back to the impacts on production planning. So on the efficiency side, automation reduces lead times and optimizes production schedules. Accuracy, AI and ML enhances forecasting, reducing errors and aligning production with the demand. As you already discussed, forecasting is related to demand, and insights will provide analytics on how to dynamically adjust and do a predictive maintenance. While the production planning, or while I'm on the manufacturing floor, I always see that the plant maintenance guys used to do some maintenance in the middle of the production line, stopping it so that they will stop the entire manufacturing process and do some maintenance. And they will take that as downtime, and they will discuss in their TPM regular meetings on how can we do, or how can we manage our manufacturing even more efficiently by reducing the downtime. So these are some of the insights that we can get by using the hyperautomation. What are the key points? Equipment failure prediction accuracy is 90%. Unplanned downtime reduction is 35%. Now, technology is powering hyperautomation, as we said, RPA. It automates MRP runs. MRP is one of the key component. MRP is nothing but material requirement plan. We will try to monitor how much material is required to produce a finished good, and how can we plan so that we will not have stock deficiency during our manufacturing, producing a particular component, or any end product, right? So by using RPA, it reduces manual data handling by 70% and minimizes errors by 90%. So AI, it predicts and enhances maintenance scheduling. So there is always a maintenance. Usually every manufacturing production facilities will have an 8-hour or 12-hour shift, and they will have maintenance downtimes, and they will schedule it and do some maintenance. They might apply oil or tighten some screws or some kinds of maintenance, right? By using the AI, we can predict what can be the maintenance schedule. And by using ML, we can do some adaptive learning for better production scheduling and anomaly detection. There will be always some anomalies, like if you are preparing a food, or if you are trying to make a car, or any kind of manufacturing facility, there will always be some kind of anomaly that will be detected. By using this ML, we can do an adaptive learning and learning on the go, so that we can understand what these anomalies are. By using process mining, we can identify process inefficiencies. What is causing process inefficiencies, and how can we use this process mining for our continuous improvement? So statistics say that process mining can reduce production cycle time by up to 15%. So coming to the challenges and ethical considerations, we always have challenges. Like any disruptive technology, hyperautomation faces some challenges. So when I always speak to the steering committee, or when I speak with the vice president of manufacturing or CEO of any company who has a manufacturing facility and who is the head of manufacturing, they always say that we always have concerns about data privacy, and they always have concerns about integration. Why? Because on one side, we are going to use machines. On one side, we are going to use software. So software and hardware combination, in integrating both of them, is a very complex process. As we all know, there is something called as manufacturing engineering systems, or MES, where it can adopt or integrate into any kind of different software technologies and make sure that the manufacturing is going smooth without causing any kind of issues. So then that is one way where we can see that there is an integration with complex manufacturing systems is always a big issue, and multiple challenges are faced at that end. And on other hand, there is something with data privacy. Always there is data about customer or a vendor or some kind of financial data. So most of these executives, right, 31% of them are worried about the sensitive production and customer data often involved in the manufacturing facilities. So these are a couple of the challenges. So now, what is the future of SAP PP and hyperautomation? Looking ahead, hyperautomation is set to become a cornerstone of Industry 4.0, which is the latest. Advancement in AI and ML will unlock new possibilities in production planning, from self-optimizing systems to fully autonomous manufacturing execution. With a projected market growth of 18.7% CAGR, as I said before initially, reaching 26.5 billion by 2026, the adoption of hyper-automation technologies is not just a trend, it is a necessity. Even in our company where I'm working, they are moving to smart factory where everything is controlled by IoT, Internet of Things. There is a manufacturing head who is more investing the company's resources into this hyper automation where we can integrate multiple technologies so that he can stay ahead in the competitive, fast evolving manufacturing landscape. So now the last and final conclusion. Hyper automation integrates cutting edge technologies to transform SAP production planning. It drives sustainable efficiency gains, cost reduction, and better decision making. Organizations need to implement hyper automation because they can transform their operations, turning tomorrow's vision into today's reality. I always thank you once again to all the steering committee and all the chair committee for giving me this opportunity. Thank you.